Hello everyone. So today I'll be presenting you my classification project. So it is a project based on bank marketing. So we'll be, predicting the effectiveness of bank marketing. So the data set that we have been given was of the bank marketing campaign that was based on phone call. So here we need the information captured was in is the one here mentioned below. So the age, job, marital status, education, and if customer previously owned a term in or deposit, and the bank balance of the customer, and customer own a house and the loan. So here the camping that was conducted based on phone call. So these certain information were captured along with other information that we'll be discussing it further, and uh, they actually want they actually given us a task to predict the type of customer who actually would like to subscribe to the term deposit. So here is my GitHub link to the project. And so we'll see if there is some kind of classification uh, in the customer who would like to subscribe to the term deposit. So here is the important libraries that we need for the model. And this is the information that is actually captured in the phone marketing. So this is the information of the day on which the contract was made and the month on which the contract was made. I mean, day of the month and the month and the duration between the previous and the current, you know, this contract. So the data set has 45,211 rows and 17 columns. And we see there are no null values. So moving to data exploratory analysis or exploratory data analysis. So we see that the most of the customer who subscribed to a term deposit was between the age of around 35 to 60, and before and after that the frequency of term deposit gets decreased significantly, and there is some information relation in the job and the people who subscribe to the term deposit. So the management technician and blue collar job people who do blue collar or they subscribe to the term deposit most of the time. And similarly, the customer who has secondary or tertiary education, so they're likely to subscribe to the term deposit. And most of the customer who subscribe to the term deposit does not previously own a term deposit. And then this is the information about the housing. There is no, particular relation in housing and subscription of a term deposit. But yes, we see that the people who own a house has subscribed more. So the married people would like to subscribe or term deposit most of the time. So the balance of the customer who subscribe a term deposit is between, below 35,000 or 3,500. And the type of phone that a customer own. So the people who own cellular type, subscribe most of the term deposit. And here is a pie chart that will display the age group who subscribe to the term deposit most of the time. So here it is that the age group of 32, 31, 33, we basically the people who are in their 30s has subscribed most most of the term deposit. I mean, the most of the time. So the, it is around one third of the term deposit that the data has captured is for the people who who are in their 30s who subscribe to this term deposit. And this is again a pie chart. So the blue collar job people, management, uh, people who are working for management and technician subscribe to the term deposit most of the time. And similarly for the education formation, and this is the housing. The people who own a house subscribe to the term deposit and their marital status. So we see that there is no null values in our data. So we'll be checking outlier and handling them. So our model may not get impacted due to the outlier. So here is the outlier box plot for the age. So people, having more than 70 year of age usually do not subscribe to the term deposit, but they have subscribed in certain number of times. So we will be removing them. And similarly, the balance, the customer who has, there are very less customer who has, the bank balance of more than 3,500. So we'll be just dropping all those, we will not be capturing them in our model. And then this is the information about the duration. So we'll be dropping all those duration, not be dropping, will be just replacing it by mean if the duration is more than 550 days. So after dropping all these, there are certain null values. So handle this null values by just dropping them. So these are all the null values that we actually, actually want to drop. So these are 554 and the balance 406, 4,651. So here, if the customer is already a subscriber of the term deposit, so we'll be giving him a yes and no. So we'll be, doing feature engineering to convert a categorical variable to to a numerical. Similarly, for the education factor, so if the information is unknown, we'll take it as zero. And primary, secondary, ternary, it is already a type of numerical hierarchy. So based on which we'll be converting the educational category to the numerical the categorical uh, educational feature to the numerical. And similarly, default for the default housing loan, customer own a loan or not, and we'll be converting this month feature to the numerical feature. So if the contract was made in January, so January will be given a one and so on. So the month feature now this will be dropping it as it is a categorical feature, and we'll be converting other to the one will be doing one hot encoding for marital status, job, contact, and the output. So after checking this correlation, this correlation, I have. For pre-book processing, I have taken certain all this column as a X categorical X feature, and if the customer subscribe to the term deposit, those customer who subscribe to term deposit will be, will be taking it as a Y categorical variable. So if the I mean the information about the subscription. So if the column contain the information, so if they subscribe, it will be a one, or if that does not subscribe, it will be a zero. So just finally checking any if there is any null value. So here we'll be doing a min max scalar. So as the data will be not the data that we are having is not in the same scale. So the first model that we'll be trying is a logistic regression, after just scaling the data. So the data here was able to give 90% accuracy. Here's the confusion matrix. The other model, next model that I'll be trying here is the decision tree classifier. So I have done an extensive, hyperparameter tuning. So if I just try to run it, it will run for a longer time. So I will not be running here. I know the best parameter that I have actually, searched for this model. So again, we got the accuracy of 90% on test data and 89% on train. So the third model that I will be trying is random forest classifier. Again, I have done a very extensive hyperparameter tuning. So, so here the test accuracy and the train accuracy that I was getting was, within one absolute percentage. So it is 89%, 89.87% of the train and 89.28% in the test. And the fourth model that I have tried here is the XGB classifier. So here I was able to get it 93% in the train accuracy and 91% in the test accuracy, so on. So the information conclusion of this project is that when we'll be further conducting our marketing campaign, we may classify, customer to a certain extent, where customer would like to subscribe to the term deposit. So the effectiveness will be, you know, will not be giving the information of those customer to the representative who will be actually doing camping over the phone call, who are, you know, less likely to be subscribed to a term deposit. So this uh, likely information the customer can be, you know, uh, can be enhanced to 90%. So if uh, they use our model, so 90% of the time, the decision tree classifier model would help them, um, 90% of the time, to find the customer who would actually like to subscribe to the top deposit. So this may be used further to enhance the effectiveness of this marketing campaign, and would the marketing cost will be decreased significantly. So that would be all in the classification project for today. And thank you for your time.